Today we're doing an experiment on density, and this one's broken up into 3 or 4 parts. So for the first part, we want to show that density is an intensive property, meaning it doesn't depend on the amount that we have. So what we're going to do is we're going to take a little bit of 100% ethanol, add it to our graduated cylinder, get a couple of different mass and volume measurements so that we can find the density of each of these amounts. So first thing we'll do is get about 2 milliliters in here. Again, the exact amount doesn't matter because you're going to measure it. So if it's a little above or below 2 milliliters, it's not a big deal. There we go. So again, just like with the glassware lab, we need to look at our increments, measure between our increments. So this one, each increment is 0.1 milliliters, meaning we'll be estimating that second decimal place. And this one looks like it's right on the line, just above the 2 milliliter mark. So we'll call that 2.1. But again, to 2 decimal places, that would be 2.10 milliliters. And our mass is 1.60 grams. Again, I'll go through all of the calculations for density, average density, and all of that stuff at the end. So now that we've gotten our 2 milliliter aliquot, I'll fill it up to about 4 milliliters. Right about there. A little more. That was a little too much. Let's see, between 0.2 and 0.3. Call that 4.29 milliliters, and the mass is 3.37. Now that I've done the 4 milliliter amount, let's go ahead and bring it up to about 6. There we go. Let's see. It's a little below 6, so 5.92. And 4.65 grams. And our last one, the 8 milliliter volume. Let's see. There we go. A little over. It's between 8.0. Might be right at the 8.1 mark. Let's do that. 8.10. And then 6.32 grams. So for our next part of our experiment, we're going to start making our density column, meaning we need the density of a couple of different compounds. So that means we need mass and volume measurements for a lot of these. So the first thing I'm going to use is some mineral oil, and we need about 20 milliliters. Again, the exact volume is not a big deal because we'll be recording that. I did this before the video started, but make sure when you put your graduated cylinder on, you tear it out to 0 your scale, so you're just getting the mass of your mineral oil. For this one, let's see, between 24 and 25. Yeah. Let's call that 24.9. That's not pencil. And the mass is 20.93. So after measuring the density of water the same way, we're going to move on to the pennies. Again, I'm going to video one of them. You guys don't need to watch me do all of the trials. So the first one we're doing is pennies from the 1960s. So make sure if you were in person, you would want to record your values. To get the mass of the pennies, okay. So once we put the pennies on the scale, we'll get the mass of the 5 dry pennies as 15.40 grams. To get the volume of pennies, what we're going to do is do something called the displacement method. So we have some water added to a graduated cylinder. Its initial volume, I'm going to go ahead and take as 20.8. And then we're going to add our 5 pennies in. And the water level should increase. There we go. And that new volume is going to be our final volume. The change in volume would be due to the pennies. 2.5. So we have our change in our initial volume, our final volume. We'll get the change in volume, and that is the volume of the pennies that we'll use for the density. And again, we can get the mass per penny and the density of each penny from calculations that we'll do at the end. And then I'll go ahead and do the other decades of pennies to provide data. So once you get all of the data for your pennies, part 3 is actually going to have you use that data, as well as if you were in face-to-face, all of the class groups data or all of the data provided to you to plot the density of pennies over decades. But the post-lab questions and slides for that will help walk you through those. The last thing we need for our density column is our cork, and we can't use the displacement method with this because the cork will float, so the volume won't significantly change if we put it in. But because this is more or less a nice geometric object like a cylinder, we can measure the dimensions and calculate the volumes that way. So first thing, I need to measure the height of the cork, which is about, right at the 3.9 mark, so 3.90 to the right number of decimal places. And it'll be easier in this case to measure the width or the diameter, which is about 2.1 centimeters. And then from there, we can use the volume formula. Volume equals pi r squared h. R is our radius, so we would just take our width and divide it in half to get our radius, and then plug everything into the formula to get our volume, which I'll do again towards the end in a separate calculation section. So now that we've gotten the densities of all of our components, we can actually add them to our density column, and a density column is really just a visual representation for how all of these densities work out. So if I add the water we used, add the mineral oil, pennies up. Pennies and our cork. So what we can see is we get some very specific layers. We can see the pennies at the bottom. There's some liquid in the middle here. We've got another liquid on top of it, and then we have our cork. And what we can see is when we look at all of our densities, the densities will actually tell us what order these add up in. And so this is a visual way to look at how those numbers compare.